Okay, so today we're talking about electrical work, power, and energy. Our objective is to be able to use mathematical thinking to find the energy in an electrical system. So this works similarly to the work and power we've already done for kinematics, things that are on the big scale. Now we're looking at electrons and the work that that's doing. The units are still in work in terms of watts, and the equations we're going to use, these are on the reference table. It's power is equal to potential difference times current, current squared times resistance, potential difference squared divided by resistance. And here's an example. It says an electrical appliance draws 9 amperes of current. So this is current when connected to a 120 volt source of potential difference. So that's potential difference. What is the total amount of power dissipated by this appliance? So P is what we're looking for, power. Current is 9 amperes. Potential difference is 120 volts. So P is equal to potential difference times current, and that's equal to 120 times 9. And you get 1080 watts. Okay? The next thing is the work. As if you remember, that's the change in energy. The equations we're using are still on the reference table. Work is equal to power times time. The potential difference times current times time, which is equal to the current squared times the resistance times time, which is equal to the voltage or potential difference squared times time divided by resistance. The units are in joules or in electron volts. So here's an example. It says an electric toaster is rated to 1200 watts. This is power at 120 volts. This is potential difference. What is the total electrical energy, which is work, used to operate the toaster for 30 seconds? Okay, so we know that the power is 1200 watts. The potential difference is 120 volts. The work or total energy is what we're looking for. And the time it's operating in is 30 seconds. So we're looking for the total energy, work, and it's power times time, this first one. They give you extra information, and so you don't need this potential difference. And so you can just do 1200 times 30 seconds, and that is equal to 3.6 times 10 to the 4th joules. Okay, and as a reminder, potential difference is equal to work divided by charge. So this time we're going to practice in electron volts. It says how much work is done moving 6 electrons, this is Q, through a potential difference of 2 volts, which is V. So it's Q is equal to 6 electrons. The potential difference is equal to 2 volts, and we want to know what the work is. So we can solve for work. So V times Q is equal to work. And that's going to be 6 times 2. And that's still work. And that's 12 electron volts. Okay, thank you.